The perimeter is the measurement around a triangle, whereas the area is the measurement of the space taken up by a triangle. Let's talk about the anatomy of a triangle one more time. All triangles have three sides, three angles. The altitude of a triangle is the perpendicular distance between the base of a triangle and its opposite angle. The key word here is perpendicular, so I need a line that makes a 90-degree angle with one of the sides, goes through the triangle, and cuts directly to the opposite angle. When we make an altitude, the base is the side that we're drawing the perpendicular altitude. The base of a triangle can refer to any of the three sides. It's perpendicular to the altitude. So in this case, here's an example of an altitude. It makes a 90-degree angle with one of my sides, and it goes straight to the opposite angle. Here's another example. It makes a 90-degree angle with the side and goes directly to the opposite angle. And yet another example. It makes a 90-degree angle with the side and goes directly up to the opposite angle. These are altitudes. The base, in this case, would be this side. Notice it makes a 90-degree angle. In fact, because of what we know about angles, this makes two 90-degree angles directly next to each other. We can look at the altitude as the height of the triangle. Altitude's a much better term for it because height usually refers to an up direction, where in this case we've seen altitudes that go in all directions depending on which way the triangle's turned. We can also notice that this altitude split our triangle into two right triangles. Because we ended up making two right angles, we split it into two right triangles. That eventually opens us up to use trigonometry, Pythagorean theorem, and our 30, 60, 90 and 45, 45, 90 triangle relationships. Now that we have a couple of the terminology pieces out of the way, we can start looking at what area of a triangle actually is. The area of any closed geometric object is the number of unit squares that can fit inside of it. So in this case, a unit could be anything: centimeters, meters, inches, miles. We're just going to refer to them as units when we see them in a grid like this. So based on this triangle's shape and size, I can see how many of those individual squares, those individual units, fit inside of it. I have 1, 2, 3, 4 whole units. The other portions are parts of those whole units. So I see here one whole that's cut off. If I take that piece that's cut off and flip it, it fits perfectly there. So now I have 5 units. I can do the same thing on the opposite side. That's 6, 7, and 8 units. So we would say that this is 8 units squared. The unit for area is always squared. So if it's feet, it's feet squared. If it's inches squared. If it's centimeters squared. Looking at area this way helps us understand what we're looking at, but it doesn't help us find the area of a triangle. Not all triangles are going to be put on grids, and not all are going to be that easy to count out the individual squared units. In this example, we have a lot of little parts of squared units, but it's impossible to see what portion each of those little parts adds up to. So instead, we have to look at a formula. Our formula is area is equal to 1/2 times the base of a triangle times the height of a triangle. This formula makes more sense if you think of it as 1/2 times base times the altitude of a triangle. Because height usually refers to the vertical distance of an object, altitude makes more sense because we don't need to have it going up and down. Altitude is the line that makes a 90-degree angle with one of the sides. That side is called our base, and it goes directly up to a straight angle. We can simplify the formula as A equals 1/2 B times H, base times height, or altitude. In a case of a right triangle, it's very easy to find the height. It has a more traditional definition of height in this case, because I know how tall this triangle is. It's 3 inches tall. We could also look at that as an altitude. An altitude is any line that makes a 90-degree angle with one of the sides, which this side does, and it goes straight up and hits the angle opposite the side. So this side of the triangle is also my altitude. Knowing what I know, I can start to plug into the formula. 1/2 times base times height. The base is 4. I know the base is 4 because it's where the altitude is making that 90-degree angle. My altitude is 3. Again, this fits more of the traditional definition of height based on the way the triangle is set up. Now I just need to follow the order of operations. 1/2 times 4 gives me 2. 2 times 3 gives me 6. Look at the units. It started as 3 inches, 4 inches, 5 inches. So it should end up with 6 inches squared. Units are always squared. Let's try a couple examples. So let's start with the triangle on the left, the green triangle. We always start with our general formula. Area equals 1/2 base times height. Now they gave us an altitude in this case. I know they gave us an altitude because most altitudes A are represented by dotted lines, and most importantly B, that makes a 90-degree angle with one of the sides and connects directly up to the opposite angle. So the altitude is 5 centimeters. The base, which is the side that the altitude makes the right angle with, is 7 centimeters. So I plug those in. 1/2 times 7 times 5. Half of 7 is 3.5. 3.5 times 5 is 17.5. The units were centimeters, 5 centimeters, 7 centimeters. So my final answer's unit will be 17.5 centimeters squared. All units are squared. To understand why, when we were multiplying 1/2 times 7 times 5, we weren't just multiplying 7 and 5. We were multiplying 7 centimeters times 5 centimeters. Think exponents. X times x gives me x squared. Centimeters times centimeters gives me centimeters squared. We're going to do the same thing with the right triangle, the red one. Take the general formula, write it out. A equals 1/2 times base times height. My height is my altitude. It's the line that is perpendicular or makes a 90-degree angle with one of my sides and then extends straight up to the opposite angle. So my base here is 3, my height is 7. Be careful with the term height. In this case, you might be inclined to find another measurement for how tall this triangle is. Height is better defined as the altitude. So my base is 3, my height is 7. Now I just need to follow the order of operations. 1/2 times 3 is 1.5. 1.5 times 7 gives me 10.5 yards squared. Again, it's yards squared because we did 3 yards times 7 yards. Yard times yard equals yards squared. On your own, evaluate the area of these 3 triangles. The height is the measurement of the altitude. The altitude is a line that goes and makes a perpendicular or 90-degree angle with one of the sides and extends straight up or straight over to its opposite angle. The base is always the side that the altitude makes a 90-degree angle with. Keep in mind, the height is not always the height. The base is not always the base, or at least the base and height based on how we think of it. In number 2, for example, we're given 12 kilometers. That is our base. It's not at the base of the triangle, though. 9.1 kilometers is our altitude. This represents our height, but notice it's not the height of that triangle as it's drawn. If you turned that triangle, you could have your base on the bottom. You could have the altitude represent the height. After evaluating, remember, units are always squared. Centimeters squared, kilometers squared, miles squared.